Hi, today we are going to start the calculations of, remember, substance undergoing combustion. It's page 31. Let's look at the slides again. Right, you can see here. Okay, we talk about here. If you, well, I put down here, let's put in blue lah. It's here. Combustion data. Okay, right. Rub off the here. Combustion. So I want you to see how the question, what kind of question they ask. Combustion of what? Okay, mainly they will ask you combustion of hydrocarbons. Okay, hydrocarbons. They ask you a variety. So you better be prepared for it. Okay? CXHY. It can be alkanes, alkynes, doesn't matter. And it also can be thionyls. Well, thionyls are like H3SH. These are found in smelly onions, your armpit, and skunk, whatever. Okay, these are all can burn. No, can also found in your alcohols. Okay, whatever it is, it doesn't matter. All right, they all will burn. Okay, like this one here. I'll show you how the different variety is. Yeah, because by composition of mass we've done already, like 30% of magnesium. Okay, 20% of sulfur, and maybe 50% of oxygen. Okay, this is how you calculate the empirical formula. Right? So, but now here's combustion. Okay, now I've done with you that the last time in deriving the formula for the combustion of hydrocarbons. If you remember. Okay, now let's go to the question. Where's the page? 31. Now this is important. This formula is important. Remember, I actually helped you to balance off this whole thing here, right? If you remember, if we start with here, is okay, the hydrocarbons here, CXHY, right, and oxygen, O2. Of course, at first maybe I just go with that. So we don't have this one here. So we know that it will give you carbon dioxide and water because complete combustion, okay. You won't get carbon monoxide, you won't get carbon, just carbon dioxide and water, right? So you just take this as one here. Yesterday I tried to be very fast because time was catching up with us. See, it's one here, stiochiometrically one, okay, one more here. Say one more here. I don't know how many moles here. I need to balance here. They always ask you to find this value here. Okay? Let's say you put an arbitrary value of A, so I say A here. So I don't know what is A. But in one here, there's X atoms of carbon here. So here, because carbon dioxide is C1O2, so there must be X in front, because X times 1 is X in. Yes. So hydrogen here is Y, because 1 times Y is Y. So H2, there's 2 here. So Y over 2 times 2 is equal to Y, no, Y here. So this balance here. So now I need to find how many oxygen atoms here on the left hand side must equal to the total number of oxygen in the right hand side. Okay, simple maths. So here, if I put A here, A times 2 will be 2A number of atoms. Now here, right, in here you can see, so X. Okay, 1 mole of carbon dioxide is X. 2 atoms. So X will be 2 times X now. Okay, from here. So here, oxygen coming from here is Y over 2, right? So the total of them of oxygen on the right hand side is 2x plus this whole thing here. Okay, so now we go to the mathematics. We add up, right? And A over 2 here, so we get x. Okay now, right? That's why we have x plus y over 4. Okay, so the answer you can see here, right? X plus y over 4 over 2. So now this is very important in the sense that this is stoichiometry balance in X and Y. So you can say what can say here, I'm going to put blue color. So we distinguish it here. So here you can say 1 mole. Okay, you can say it out. Say it out. 1 mole will react completely with X plus Y over 4 moles of oxygen. Completely, no. It's complete reaction. That means after reaction here, no more. Here, no more. Okay? And what is formed? X moles of carbon dioxide. And Y over 2 moles of water. Now, this water here is very tricky. You can see some questions there. Oh, it's room temperature, RTP. If RTP, that means it's become liquid, isn't it? So H2O is liquid. So it will not affect the volume of gas. But if the temperature here is above 100, which is one question I give you, temperature, let's say here is equal to 150. That means this will be H2O what? Gas. They will tell you. So you have to be careful. So make sure you balance off all the equations. So if there's 1 mole here, you write with X plus Y over 4 moles of oxygen, and you give it X moles of oxygen, carbon dioxide, and Y over 2 moles of water. Okay? Now, to change moles to volume, right? To volume, it's not in Form 5, but I will do it for you. Okay, I will do it for you. I'll go to the other side to do it for you. If you want to find out why. Now here, right? We start with here. Okay. Okay, so we have cannot pass. Never mind. I should have done it earlier. I'm sorry. No planning. Never mind. Right, a bit more. Y over 4 O2 give you. See, I can memorize. So can you? You are younger than me, is it? All you young chicos. Y over 2 H2O. Now that means here I can say it's 1 mole here, right? We'll react with X plus Y over 4 moles of oxygen here. I'll give X moles of carbon dioxide here, and Y over 2 moles of water here, right? So this is how you say it out from the stoichiometry. Now change to gas. Assume this is liquid. Okay, assume that temperature. Well, it's RTP. Okay, so we're concerned with only this gas. This is your gas. This is your gas. Okay, we won't talk about water. Okay, never mind. Easier. Okay, we start with that first. Now, which means to say, right? Okay, 1 mole at RTP. What is the volume occupied? We know there's 24.0 dm. Yes, what? Yes. So this, if it's this here, it will be X plus Y over 4 times 24. No, dm cube. This will be X times 24. Okay, dm cube here. This will be same if it's gas again, right? If it's gas, okay, let's say it's gas. Let's say it's gas, okay? I don't let's confuse you. Okay, so let's say I ratio it out. I all divide this by 24. Okay, I want to take the common ratio. Okay, so this will be 1 dm cube. We'll write with how many dm cube? X plus Y over 4 dm cube. To give you how many dm cube of oxygen? X dm cube of oxygen. I want to change this to cm. Okay, so 1 dm cube is 1000 cm cube. So this will be X plus Y over 4 times 1000 cm cube. This will be 1000 cm, cm cube. I want to change some more. All divide by 1000. So get 1 cm cube. We'll write with X plus Y over 4 cm cube. We'll give you 1 cm cube. See now? So now this is the basis now. So you can see from here. Okay, I change the moles. Moles into volume. Okay, right? So now this is very important because the question always give you, give it in volume. Let's go to the first question, okay? Right? Remember this is one, huh? So actually, let me give it blue, okay? Right? Actually, you can use the number here, 1. x plus y over 4. Because it's the same, x and y over 2. See now? Okay, the number of moles in the stoichiometry of the equation will represent the volume. So that's quite easy, isn't it? But I show you how they convert it. Okay, now let's go and use this now. All right, now, this whole time will be just on this. I hope I can finish it here. So here, now the first question here. See, all right. Now normally they would say 10 cm cube or 25 cm cube. Okay, let's get the first one. 10 cm cube of the hydrocarbon was exploded with 60 cm cube of excess oxygen, and after the gas mixture is shaken with alkali. Why alkali? Alkali, because after shaken with alkali KOH, or can be any OH. Why? Because it will absorb the carbon dioxide. See now, because carbon dioxide is what? It's acidic. Okay, so that's the reason. Right, the volume shrunk. That means the gas shrunk. It means that the carbon dioxide was removed as much as 20. It means it's what? It's the volume of your carbon dioxide. The final volume is 25. So it means 25 is the excess what? Excess. Right here is excess oxygen. So here they started with 60. Excess is 25. That means how much reacted? So volume of oxygen reacted. So these are things you need to know. Because how much? With 60 minus 25. See now, see? So it's about 35. So these are the things you need to know now. Yeah. Okay. So what's the formula of the hydrocarbon? Normally the formula here you find out is always the molecular formula. Always. They will ask you to convert it to empirical formula. Okay? Let me show you how this is done. Right? Experimentally, okay? With some visual. Okay. Oops. Zoom blank. Okay. Right, I think this is a nice place. Okay. Let's say I put a hygrometer or something like that, okay? A long tube here. Okay. And then I put here, not very good drawing. Huh? Okay, mercury. So I put mercury here. If this is a capillary tube, it will go up to here. Right? This mercury. Mercury Hg. Of course, the height here, you will know that it will represent the pressure to be 76 cm cube. And here is all vacuum. C-U-U-M. Can't spell it myself. Now here, let's say there's a batteries, and so here there's a spark plug. Okay, tick tick pop pop, and then it will cause thing to burn. Okay, so now this is the starting point. Time was 0. And the second one. Okay, I'm going to put a tube inside here. I'm going to pump inside here the hydrocarbon. CX. I'll do slowly because the pen not stable. Okay, how much they pump inside here? According to this question here, 10 cm cube. Okay, see now, 10 cm cube. So, right, I'm putting 10 cm cube here. 10 cm cube. So, I draw smaller. Okay. This molecule. Okay, tube here, I pump inside. So, mercury, meniscus up. Of course, occupies here, and then of course, then it go out to this volume. Okay, mercury. So this first one is how much? 10 cm cube of what? Of CXHY. Got it? Okay, of course here is your battery and your spark plug. Okay. Then I pump in what? You look here, pump your explode with 10 cm cube excess oxygen. That means I'm going to pump oxygen inside. Okay, pump inside here again. Oxygen. Okay, oxygen. So of course, if oxygen pumps here, how much? I forgot how much. How much? 60 cm cube. All right, 60. So 60 cm cube of oxygen. That means here will be a total of how much? 70, is it? So I'll rub it off here. Okay, see. No. let's say here, I'm going to put the thing again. This actually helped me a lot. No, I'll tell you. No, I cannot draw. I won't do it. Okay. So here be plus how much? Plus 60 cm cube of oxygen. A total volume of how much? Total equals to 70 cm cube. You know, now this is before ignition. Then you will start the puck, and it will burn. It's combustion, right? So you burn it. So see here, after mixture gas was exploded. So the word exploded means you cause it to burn. Okay. After exploded, the gas mixture was shaken with alkali, right? The volume is shrunk by 20. Okay. After it burns, right? It got a new volume. Okay. Burn. Don't care lah. Okay. Here. All right. Same thing here. Okay, let's say burn and then this. They didn't tell the volume, is it? Don't care, that's the volume here. Okay, so after burning, all right. So inside here, after burning, guys, is after explosion. After explosion. Okay. So what we inside here? Now you must assume that there's excess of oxygen. That means no more no more CXHY. No more. Tak ada lagi. Oxygen got. There's excess. Why? Because they tell you that excess oxygen, right? So the excess means to make sure that all the hydrocarbons are burned up. And of course you got carbon dioxide. And of course you got water, H2O. So because of the temperature, the water will be down here. So the water will not occupy the volume here. So the volume here is basically these two fellows. Okay. So what they do is they put in a tube here and pump in NaOH or KOH, which is what? Alkali. Remember, mercury is in. So what this liquid is lighter than pop, go away, and you shake the fire, and this one will absorb. Absorb all CO2. And finally, they give you the volume here. Let me check. So, see now, right? The volume of the gas shrunk as much as 20. The final volume was 25. So 20, 25. So what is shrunk? It's shrunk, okay? It's shrunk. Really bad drawing. So here, I'm going to use red. Sorry. Red. Come on. So remember here. Nicely here. Okay. So it was here, and it went up strong to here. Okay. So the first here. Okay. Let me go up to here. So shrunk by this one. So let me say this amount shrunk. So the volume shrunk. The volume shrunk will be your carbon dioxide. How much is it? 20 cm cube. And the remaining volume here, volume is what? Excess oxygen. Excess. And how much is it? I think it's 25, isn't it? Okay, the other side. 20, correct. The final volume is 25 cm cube. See now, what's the formula of hydrocarbon? Which means now this is a lemma. This is equals to 25 cm cube. The whole thing now rests in this here. Okay, here, right? Let's see. I'm going to use blue so that it will differentiate. So now, 1 cm of hydrocarbon must react completely with X plus Y over 4 cm cube 4 of oxygen to give 1 cm cube of carbon dioxide. Now, how much did I use in the beginning from here? 10, isn't it? So for 10 cm cube, how much oxygen will I completely react with 10 cm cube? Will be x plus y over 4 times 10, is it? Is not simple. And how much is this? Be 1 times 10, is it? It's not. So this at the end of the experiment, all this is habis. I'm going to put red again. So no more. Now this value here, how much of it is being reacted, totally reacted with the 10 cm cube of hydrocarbon? I know from here, right? Now excess is 25. Original, how much? 60, right? So totally reacted with 10 cm cube. So volume of oxygen reacted is equals to 60 minus 25. Which I told you now is 35 cm cube. Now here, how much of carbon dioxide is formed? Right? Right? Volume of CO2 formed is equals to how much? Now, of is equals to here is, okay, this x, what is it? Okay, sorry, this is x. This is, sorry, this. I say, what you tell me? X here. Okay, this x here. Huh? Okay, so here's x. So it's x here. So, yeah, what am I doing? I got confused. X. Okay, 10 means 10x. 10x. Okay. So 10x. So it's 10x. So it's how much is it here? Come on, 20. 20. So 20 is equals to 10x. Right? It's 20 cm cube. 35 cm cube is equals to how much? X plus y over 4 times what? Times what? Times 10. See. So can you solve? So here I will start first again. So 10x is equals to 20. X is equals to 2. Right? This is for carbon dioxide. For oxygen, right here, x plus y over 4 times 10. How much oxygen is used up? 25. So here, so y, remember 10 here, so x plus y over 4 is equals to 2.5. It's not. X is 2, right? So bring 2 over, come here. So y over 4 is equals to 0.2. Hey, something is wrong. Sorry. What I do here? I think something I put wrongly here. Carbon dioxide is equals to how much? 60 here, 70. Carbon dioxide I got here, 10, 70. Shrink by how much? Let's check again. Something is wrong. Shrink by how much? Shrink by 6. Okay. Shaken by that is shrunk by 20. So carbon dioxide is 20. Okay. Carbon dioxide is 20. Carbon dioxide is 20. Which is correct. Okay, 20. Right? So it's 2. 20. 32. Which 32? Oh, sorry. I was looking at another question. Never mind. Okay. So here the water here. Okay, here is, see, so it's a messy thing, I tell you. Let's see again. Okay, that means here will be correct. So the volume, okay, X is equals to, we know that for carbon dioxide, X is equal to 2. Okay, right? Because why? Because 10X equals to 20. So for carbon dioxide, 10X is equal to 20. So X is equal to 2. Now for oxygen, okay, let's do again. I'm sorry, I go the wrong place. Okay, now right? Remember, use 10, isn't it? So it's X plus Y over 4 times 10. X plus Y over 4 times 10 is equals to, now for 10 here, how much of oxygen was it reacted totally? At first we use how much? 60, isn't it? Right? You can see here is 60. Okay, 60. Right? 60 here, and how much remaining unreacted is 25. So 60 minus 25, right? So it's 60. So it's 60 minus 25. Okay? Right? It's equals to how much? 35. Not 25. I was wrong there. So X is 2 plus Y over 4 times 10. Yes. Okay? So 2 plus Y over 4 is equals to, of course, 3.5. Right? We bring over is Y over 4 equals to 1.5. So Y is how much? 1.5 times 4 will be 6. That's not. Yep. That's not. Okay? So our answer is C2H6. Okay? So I made a mistake here. It's 2.5. I don't know how to do something like 2.5. Here, the answer is here. Okay? Okay? So I should use this 35 instead of 25. So here is wrong is, here should be a bit of a. So be careful. It's all messy as well. I should have write out carefully. Okay. After you see worse, after you got, okay. So if that's the case here, right, here be, right, here be 3.5. Okay, then you get correct. It's not. Okay, so here will be 1.5. Okay, you bring 2 over. Okay, so you put here. So correctly, you would refer to this with 3.5 minus 2. Right? So Y over 4 equals to 1.5. So Y equals to how much? 1.8 times 2? It's 2, 6, 8. Okay, so that's why it's here. I'll put the blue color. Sorry about the mess. Okay. Okay, mistakes make you stronger. Right? Now this is how you do the work. Okay, now let's do every one of them because it's quite tricky. Okay, now this one here is quite simple, I think. Okay, now let's try that. Let's try some passive questions. Okay, passive questions. Okay. Here. Okay, a mixture of 10 cm cube of methane and 10 cm cube of ethane. Now got 2 gas mixed together. Okay. Okay, I do here methane CH4 and C2H6. You don't know means you die, the formula. But spark with excess oxygen after cooling at room temperature, the residual, that means the left behind gas, must pass through aqueous potassium hydroxide. It means absorb carbon dioxide. What volume of gas was absorbed by the alkali? Which means ask you to find what gas? The volume of carbon dioxide. Find what's the volume of CO2. So here again, you can now here don't have to memorize the formula equation. It's just balance equation. Yeah, quite simple. So 2 plus water. Okay, now let's pick it up. Otherwise we mess up the whole thing again. Plus O2 gives you CO2. Balance it out. I did balance it. Okay, 2 to O. This will be 1. Okay, 1 here, correct? Is it? Oh, here's 2. Is it? So 2 and 2, 4. It will be 2 here. Here 2, about 2 in front, is it? 6 here with 3 here. So 4 oxygen plus 3, 7 is. So this is 702. So now 1 cm will react with how many cm? 2 cm. To give you how many cm? 1 cm. Okay? So don't care about this one here. Right? Room temperature, ma. Right? So it's very liquid. So if you use 10 cm cube, okay, how many will it react with? 20 cm cube. How many is from? How many? 10 cm cube. So all this is gone. They didn't say to find the excess oxygen here. It means how many CO2 are from? 10. So now here again 1 cm cube react with how much? 3.5 cm cube to give you 2 cm cube. Is that? Yeah? So if I use 10 cm cube here, how much is this? 35 cm cube. How much is here? 20 cm cube. You see that? So, right, all this reacted. So 20. So 20 plus 10, how much? 30. Okay, C is the answer. Okay, simple, is it? Now this one here, you see, this is the like what we do. This whole thing is only 1 mark. No. Later, the same kind of question is 4 marks. Just let me show you. So Cambridge is very good do, see that here? Same, they ask you to find the CX. Whole thing is 4 marks, man, plus 1, 5 marks. So you can see, you know, structured questions are very worth doing because they, you know, they just add marks to your total. Okay, now let's go at this one here. Okay, I might need some space down here to do it. Otherwise, if I turn the right page, I get lost like this now. Okay, where is it? Okay, here. Pure hydrocarbon used in bottled gas for cooking and heating. Okay, 10 cm cube of hydrocarbon was burned in 70 cm of excess. Okay, the final gaseous mixture contains 30 cm cube of carbon dioxide and 20 cm cube of unrated oxygen. All gases mixture. Okay, under the question. Now, then you need to write the formula. Okay, CXHY plus, remember how much? X plus Y over 4. You should remember it. Over O2 give you how much? Give you X moles of CO2, right? Plus how much? Plus Y over 2 water. Okay now. Okay. So they say, well, gas. They didn't say what. Okay, don't care. Okay. Now here. So if 1 is to X plus Y over 4 is to X moles. This is how you do stiochiometry. Okay. So if we use 10 cm cube, how much reacted? X plus Y over 4 times 10. How much is produced? 10x. Okay. So normally you use, I'm going to use a red pen. Normally you use the volume of oxygen and the volume of carbon dioxide. Normally these two are used. Once you can see that this one is used. But never mind, we look at all the examples. Okay, so the volume. So first of all, first is to deal with something here. Normally here. So the volume of CO2, right? How much is produced? Okay, you can see from here one. Okay, contains 30 cm cube of, okay, which means it's 30. Alright? So from 10 cm cube here, they found from experiment, you get 30 cm cube. So from this one is how much is it in terms of this equation? 10, is it not? So 10x is equals to 30. So x equals to 3. Easy peasy. Okay. Volume of oxygen. Remember, the unknown amount of oxygen here is this one here. But the known oxygen, how much is reacted? Okay, I mean 20 cm of unreacted. So 70 is excess. So how much is reacted? So volume of oxygen reacted equals to how much? 70 minus 20. Equals how much? 50 cm cube. And how much is this equal to in terms of the unknowns? So x plus y over 4 times 10 is equals to 50. Got it? So x is how much? 3. Substitute x inside here. Plus y over 4 is equals to 5. Yeah? Okay? So y is equals to, y over 4 is equals to 2. Y equals to 8. So 3 and 8. What's the answer? C. Okay? Alright, you can go back and try and do it again and again until you get into your bloody head. Now, here is not hydrocarbons, here is thionines, okay? Or thiols, right? The foul smell of the skunk, like some of your armpit, you know, sprays due to the number of thiols, one of which is methane thiol, CH4SH, which burns. Remember this in Singapore that I used to teach IGCSE. You know, they pipe in all this I forgot. Right? It's CO2 and hydrogen, water gas, right? Water gas, because they get it from you know, the whole breaking down of the hydrocarbons that is coming from Malaysia, which is all your cheap hydrocarbons, and they pump in steam inside and mix it and give you carbon monoxide and hydrogen. These two furnaces no smell, so if you pump go into the HDB flats, very cheap. It's a very cheap form of fuel, but no smell. So if it leaks, you will die, man. You just like a cigarette, you pom, it will all die. So the danger is that no smell. Like some of you know, like very dangerous. You backstab people, he's very smiley, nice face, handsome, beautiful girl, but oh, at the back of knives. So how do you recognize them? Put some smelly things right here. Ask them to use this perfume called methane thiol. When you go, you can smell the bugger. Okay, now this they give you the equation, it burns. The ratio, 1 mole is to 3 moles is to 1 mole is to 1 mole is to 2 moles. Now, this is the stiochiometry. Okay, and you can convert this to volume. Okay, so 1 cm with 3 cm, 10 cm with 30 cm, kind of thing. Okay, so a sample of 10 cm cube exploded with 16. Let me see, so of course in excess. It's with excess. Okay, what will the final volume of the resulting mixture when the gas is cooled to room? That means you don't care about the water. Well, so 10 will it complete with how much? Completely with 30 cm cube. Completely. And from how much? Well, from 10, isn't it? From here, 10. So now this is 4. So here, 10 plus 10. But 30 is used up. Originally, how much? Originally is 16, isn't it? Right? So excess oxygen, how much? 30. So 30 plus 20 give how much? 50 cm cube. See now? Okay? So this is how they are. So you have to work through. It's very simple, right? Use your brains a bit. Now this is a bit tougher in a sense. Okay? Now look at this carefully here. Right? I will do this with you. Today, I think we'll just do this on the your brain. Samples of 10 cm cube of each of the first 4 members of alkane series are separately mixed with 70 cm cube of oxygen, which means they start with what? They start with methane first. Okay? 10 cm cube plus 70, and you burn the burger. Each of them is burned with a total volume. And the total volume V is the residue, that means what's left behind. Measured room temperature, that means you don't care about the water. Yeah? The water becomes, steam becomes just water liquid, so you don't care. So the gas here is basically what is left behind, carbon dioxide and excess oxygen. Yes? Okay? Right? So the residual gas is basically, okay? Right? Yeah, it should burn. Burn and total volume is with residual gas measured. Okay, right? Okay, residual gas. Now let's say the first. I'm going to work at the first one. Okay. Work at the first one, and I think I want you to do the rest. Okay, not? You go and do the rest, and then you work up for yourself. Okay, methane. Remember, it's residual gas. Yo, what is this? Residual gas. Okay, that means it will be normally it will be what? The carbon dioxide plus the excess what? O2. Very hard question, a very long question. I tell you, you should give it in a structure. Here's only 1 mark. I tell you, it's crazy. Okay, CH4 plus O2. Okay, of course. You excess oxygen with complete combustion plus H2O. Balance equation first. One more, one, okay, correct. One is a carbon, is it? Hydrogen is 2, 2, so 2 here. So total of oxygen is 2 plus 2, 4. Okay, so what happens is, now times 0, okay, let's put times 0. Times 0. How much to start with? 10 cm3. How much to start with here? 70 cm3. How much to start with here? 0 and 0, okay? So after combustion, so 10 cm3 will react with how much? 20 cm3. To form how much? To form how much? 10 cm3. So don't care. Why? Because is at what? We assume it to be at room temperature. Okay? Right? Did they say no? Okay. Alright. Right. So here, see, they should actually tell, otherwise I don't know whether they include that. Now mind, we assume we don't have. Okay? So now here, excess. Okay? Excess oxygen. How much is it? 50. It's not. Yes? Yes, not? 50. Excess oxygen. These are no more. Habis. So how much? Plus 10 cm3. So how much is the residual gas? 60 cm3. You get this one correct already, you can see which is correct. Of course, D is it. Now let's do the second one. Methane, okay? I'll do for you. CH6, okay? Plus O2. Give you CO2 plus H2O. Balance equation. 2 here. 6 here, 3 here. So total is 4 plus 3, so 7 over 2. Time goes to 0. How much is there? 10 cm3. How much of this? 70 cm3. How much is this? 0 and 0. Okay. So explosion. 10 will react with how much? 10 react with? How much is times 10 is it? 35 is it? It's not. 3.5 ma. 72 is 3.5 isn't it? You don't have maths, you idiot. Okay, how much is 20 here? You don't care about sign. So 70. Excess minus the total, how much left behind? 35. Plus how much of this form? 20. How much is? 55 cm3. So you should see a trend coming down here. How much is this? This is your methane. This is 60 ma. Okay. Now here's 50 isn't it? 50. So why is what? Here's your 55 isn't it? Cannot. So you can work out for this for yourself, just to prove to yourself. So this is how it comes out again. Okay? Right? Okay. Now this one is a very commonly asked. You can see this is so simple. You don't know what to cut your head off. Okay. Complete and balance the following equation for the complete combustion of hydrocarbon, blah, blah, blah. So when they say complete combustion, it means that it cannot be carbon monoxide, is it? So it will be carbon dioxide. And must say water. Because hydrocarbons means what? Contains carbon and hydrogen only. So here, if it's one mole here, is X here, so it should be X in front here as well. Okay? So they ask you the other way. Normally they ask you this one here. Okay, so here how many hydrogen there? Y is it not? Why not? So it's 2 here, so it's Y over 2. And of course the rest should balance out itself. Okay? 2 marks, man. 1 mark for each. I think I got the marking scheme here. Okay? Okay? X and Y over 2. 1 mark each. Okay, is it? Alright. X and Y over 2, okay? Now, so when 10 cm3 of A is mixed at room temperature, always 10 on because it's easier to do. 10. With 50 cm3 of excess oxygen excluded. Okay? And 40 cm3 remain. Okay? And this 40 cm is shaken with excess oxygen and still remain. That means this one remains how much? This remain is, of course, your unreacted. Okay? This one is still remains. This is your volume of oxygen is unreacted or excess. Okay, so now this is the original. Be careful, I minus 1 is volume of oxygen in the start. So from these two, can you find your volume of oxygen reacted on? So get it down first here. Of course, this is 50 minus 30. So it's 20 cm cube reacted. Okay, how about volume of carbon dioxide? Always they ask you this two one. Carbon dioxide, when 40 is about shaken with, okay, it's still remaining. It's 10, isn't it? This one minus 1 here. Okay, so it's 40 minus 30. Because how much? 10 cm cube. Okay, all this came from 10 cm cube of A. Okay, so what is the density of the 30 cm cube of gas that remain at the end of the experiment? Of course, it's excess or unreacted what? O2. The combustion of A produces a gas reactor. It's not here so simple that you blind your eyes you can do. The volume of the gas you have identified in part 2 was produced by oxygen of A. Okay, what's the volume? Easy peasy, 10. You know. And here, what volume of oxygen gas was used up? Easy peasy. How much used up? 20. Okay. Now later, actually, I didn't print it. They actually ask you, well, what is the formula? Formula of your CXH1. Here we found already. Okay, so here what? See, so here if it's 1, so if it's 10 cm here, how many here? So x plus y over 4 times 10. How many is here? 10x. No. So I'm going to do up here. So for CO2, so 10x because how much? I mean, what's the volume of carbon dioxide? 10, isn't it? So it's 10. So what is x? 1. Okay. Now for oxygen. So this x plus y over 4 times 10 equals to what's the volume actually used up in the experiment? Oops, 20, isn't it? So for 20 here, equals to 20. So 1 plus y over 4, bring 10 down, equals to 2. Y over 4 equals to, bring on 1. So y equals to 4. Right. So what's the formula of this? No, CH4. So answer is CH4. Let's check the answer. See? CH4. Okay. 3 marks, 4 marks. Ridiculous, man. See, 2 plus 4, 6 plus 3, 9 marks. In your objective, it's only 1 stupid mark. It's really ridiculous. So I say easy to score in here. You don't get an A, you better go and die. I tell you. Okay, now I'm going to do 2 more. And then time it up for us. Okay. Let's see. 34 is 34. Okay. 3, 5, 8. Very simple one. Last one is hard. 3, 5, 8. All right, now here. Watch, yeah? P is a hydrocarbon, CXHY, a gaseous sample. P occupies 25. Now they don't use 10 anymore. See? 25. Temperature is important. Right? It's below 100, so it's to be liquid not. Pressure is normal pressure. Sample was completely burned in excess. Very simple. Final volume method, blah, 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 so that the volume produces liquid. So they tell you, did not tell you, you dumbo, you die again. Was on here. Okay, final volume. Right, that means this one will be composed of oxygen plus what? Plus CO2. Yeah. No more this CXHY already because all complete burn up. Treating with the gases with concentrated alkali, carbon, blah, blah, blah. Decrease to, that means this will be what? Decrease the volume 2. That means this is left behind, is it? This will be your excess or unreacted what? O2 here is equal to how much? 50. That means very simple. That means the volume Cn cube, right? That means from here is the here. Okay, so for the final volume to here, will be what? Will be the carbon dioxide. That means the volume of carbon dioxide formed. So this is what you do by the side here, 150. But I put down like I didn't put down. I think I'm too smart, is it? Put down here so you can check that 100 cm cube. Of course, can put the volume of oxygen reacted. Same breath is equals to how much? Starting 200. So 200 minus what's left behind 50. How much is it? 150. These are two things you'll use. Calculate X and Y. Very simple. So here, remember now here, be careful. One more give with X plus Y over 4 moles. Give you X moles, give Y over 2. So here how the volume is same. Now here how much you use? 25. No, don't put 10 again. No, you're so used to 10. So 25. How much? X plus Y over 4 times what? 25. Give you what? 25x. Yes, now. So X with 25x is equal to how much? No. Carbon dioxide? 100. So X equals to 4. Okay? So oxygen, right? Use the data to kind of, now this is the whole thing, right, the whole thing here. So what's the whole thing here? The data given to the value of the whole thing, of course, is some. 150, isn't it? Okay, see here? 150. See here. I don't know where is it? Okay, right here. So remember the whole thing here. All right. Use the data to calculate the value of. So X plus Y, right? Which is here. X plus Y over 4 times 25 should be equal to how much? The volume, how much is? 150. Yeah. So X plus Y over 4 is equal to how much? 150 over 25. How much is it? I said, no, count 5, is it? It's 5. 5. Yeah, 5. Okay, just 5 here. Okay, 5. Right? So now they say here, if you blah 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 blah, find the formula of P. Okay, so if you get to the 5, remember this one. So what is Y? X is equal to how much? X is equal to 4. So 4 plus Y over 4 is equal to 5. So Y over 4 is equal to 1. Y goes to what? 4. So it's C4 H4. Very funny. Very funny. Okay? C4H4. Right? C4H4. So molecular formula is C4H4. And this is CH. Do you know this formula? I'll show you. Right? It can. Right? If it does like this. See that? Don't assume it's wrong. Where got such thing? Cannot. See that? This is C4H4. 4 bonds in. Okay. Right? Unbranched. Skeletal. 2 possible. See that? See that? Look at the year. Okay. 17 major. I think 17 major and 20. I think here. Hey, sorry, man. It's 6. How come it's 6? Wait, let's check. C4H6. See, go wrong again. 6 times 6. Yeah, it is 6, not 5. See, I think I'm smart. 6 there. 6 then. Sorry. 6. 30, no. This 6 here. See, I also got wrong. I hurry. There's one more question, no. Never mind. You see, Mr. Lai is not a very good student. Quite stupid, no, I tell you. Okay, I find my mistakes. Oops, sorry. Right. So if it's 6 here, it's 6. Need the marking scheme 6. So if 6 here, oh no. So it's 2 here, is 8. So it's C4H8. So it's not this one here, but this can be the one you came up with this fellow here. Say, okay, wrong. I won't do the other one. Okay, I'll let you try, and then okay, that's wrong. C4H8. Don't make it wrong. Okay. So it's C4, C4H8, which is correct. See now here, C4H8. Okay, so it's 6 here. See what we got. Okay, and the formula is CH2. Right? See here. So CH2. These are unbranched, right? Scalar formula, which means this one, and you learn in Form 5. This is your CnH2n, which is so N. See, alkene. Okay, so here, of course, alkene will be 4 carbons, 1, 2, 3, 4, unbranched. So it's straight chain. Okay, now, okay. Now here, this thing you learn later, position isomers, right? Which means that it can be the top one can be here, front here and here, here and here, same thing. So 1, 2. Okay, now later you learn the thing called cis and trans isomers, but I won't tell you first. Okay, now these are the 2 ideas you can have. Okay, so you can see it will go on to the other one. Now because time is up, I tell you, okay, I just show you the question. Okay, it's not here. I found it some here. Okay, now look at it for a while. This is my video and stop it. Now this is alcohol. T is an alcohol, blah blah blah. And now see now the thing here, the temperature is over 100 now, which means that the water now comes to play. See now, so you must make sure the water, which means you need to use on here. See now, was completely burned in this one excess. Okay, oxygen. The final volume measure, blah blah blah, was 250. It means all this one will be right. Will be excess oxygen, CO2, and what? And water. So they're very tricky, which is very good. What do you think? Right? Under these conditions, they tell water is vaporized. That means it will inside here. With more water, that means the volume of water is equal to how much? Okay, 250 will decrease to that. Will decrease the volume 2. That means how much was it? How much was removed? 250 minus 170, isn't it? Which is how much? 80 cm cube. That means this was the amount. Treating the remaining mixture, blah blah, which is the remaining mixture, of course, is oxygen plus CO2, isn't it? With concentrated alkali absorbed, the volume decreased too. That means from here to here again, that means what? That means the volume of CO2 is how much? Is 170 minus 110. See, it was very good with 60 cm cube. Okay, from these two, can you solve the problem now? Okay, so this is, you look at it, now this here, look up for yourself. May, June 17, 21, number 1, I think. Okay, guys, so I think I better close here. So now we have finished properly, I tell you, sorry, properly the combustion, right? You can see here, right? I don't play a full one because you do things, but whatever is worth doing well. So do it properly, lah. Why a bit on the bush? Okay, I'm going to put a green color here. See, it's on this one here. Okay, and calculate the empirical formula. What? Using combustion data. See, So I've done all this with you. And don't say I didn't do anything, okay? Right? They didn't say what is it, but the question come out tells you. So you have to do partial questions, and you look at the marking same. I was wrong 2 times already, you know, I thought. So addition wrong, lousy in maths. Okay? So, okay, goodbye, and make sure you subscribe, you know, and put like, you idiots, you know, put like one. Okay, all right, where to end? And okay, goodbye, and start and study. You best go do over again. Okay, you don't understand, go over the video again until you get it into your